Think about this question during the lesson. Donovan ran the 100-meter race in 10 and 11 seconds. Sal ran the same race in 10 and 9 seconds. Who had the faster time?
So to decide who has the faster time, if you've ever been in a race before, do you want the highest number time or the lower number time? I want you to think about that because when I run a race, I want to be the fastest time, right? The faster time is going to win. So is that the larger number or the smaller number out of the two that we have here? Right, so when you are in a race, you want the fastest time. That would be the shortest time, the smallest number. Keep that in mind.
There is more than one way to compare decimals when they refer to the same whole. One way is to use hundredths grids.
Use the hundredths grids to model 11 hundredths and 9 hundredths.
I'm going to do this very quickly. Here we go. Oh wait, I've seen those models before in our solve and share. These are the same decimal numbers that we just worked with in the solve and share. Guys, good mathematicians make connections all the time. And having already worked with these decimal numbers should make our lives easier for solving this try this problem.
For 11 hundredths, there is 1/10 column and 1 unit square shaded. For 9 hundredths, there are 9 unit squares shaded. When you compare 10 and 11 hundredths and 10 and 9 hundredths, the digits in the tens and ones places are the same. Compare the digits in the tenths place. 10 and 11 hundredths is greater than 10 and 9 hundredths. Who had the faster time?
So we know Donovan's number is larger and Sal's is smaller. What does that tell you about which person had the faster time? Do you pick the larger one or the smaller one?
Sal had the faster time.
The smaller decimal is the faster time.
Another way to compare the decimal numbers is to use place value. The whole number parts are the same. The decimal parts are both to the hundredths. Which decimal part is greater? Eleven hundredths is greater than 9 hundredths. So 10 and 11 hundredths is greater than 10 and 9 hundredths. Sal had the faster time. How is comparing decimals the same as comparing whole numbers? For both decimals and whole numbers, you compare the digits by place value, starting at the greatest place value. Another way to compare decimals is to start at the left. Compare each place value. Look for the first place where the digits are different. 1/10 is greater than 0/10. So 10 and 11 hundredths is greater than 10 and 9 hundredths. When you compare decimals by place value, why is it important to begin comparing at the left? Comparing at the left compares the greatest place values. Now you know how to compare decimals.
Okay, so now we're going to try one more problem together. All I see is a table. What are some things you notice about this table? Did you notice there are 3 students? I noticed distance in miles, and I noticed that those distances are how far each student lives from school. I also noticed that all of these students have a distance that has the digit 6 in their distance to school or distance from school. So it makes me wonder, because we have this information, what math questions could be asked and answered using this chart. So I want you to play teacher for a second, and you can just say them out loud to yourself. You see this information. What is a math question that you could ask, a problem that you could solve using the information in this chart? Go ahead, you can just say them. So I thought of 2 questions I could answer. One is who lives the closest to school and who lives the farthest away from school. So I thought these would be 2 questions that we can explore. Of course, you can always explore some of your own as well. You can jot them down so that you can look at them later and think about them. So, in order for us to determine who lives the closest and who lives the farthest from school, we're going to need to make some comparisons. We've learned some great strategies for this, and I want you to think back to the solve and share. Darren's strategy was to use a place value chart. So I want you to pause now and enter these 3 distances into your place value chart and maybe label them K for Kaya, D for Darren, and T for Tuan. Pause now to do that. So if you haven't paused, just take a moment to pause so that you can write each of these decimals in your place value chart. And I also want you to start thinking about what is the greatest place value? Why is that important? All right, so I'm going to show you what each of these distances would look like in a place value chart so you can check your work. So take a moment now. Here we have Kaya's amount, which we would say is 6/10. Darren's amount, how would you say this? Say it out loud to yourself. 56 hundredths. And Tuan's amount, his distance, is 6 hundredths. Each of these amounts, I want you to be able to say them correctly. So go back and do that again if you would like. So we're trying to determine who lives the closest and who lives the farthest from school. So Envision highlighted the need to start on the left side of each number and compare one digit at a time. You learned how to do this before, like with whole numbers. So we're just using this strategy and we're continuing to use it through decimals. So I see there we go. I see all of the students here we're comparing those distances for. They don't live 1 whole mile away from school. Everyone has a 0 in the ones place. So the next place value would be tenths. We know that tenths are larger than hundredths. So if we compare the next place value, the tenths place, we see Kaya has a 6 in the tenths place. Darren has a 5 in the tenths place. Tuan has a 0 in the tenths place. What does this tell you about their distances from school? So yeah, Kaya has the largest digit in the biggest decimal place value and the next place value being compared. That means that her number, her distance from school is the largest distance. So does this mean she lives closest to school or farthest from school? Right, this means she lives farthest from school because her distance is the greatest. Who lives closest to school? Who has the shortest distance to go from home to school? And I see that Darren has 5 in the tenths place, whereas Tuan has 0 tenths. That means Tuan's distance is the shortest because it's the smallest number. So that means Tuan lives closest to school. So how do we justify these 2 decisions of who lives the farthest and who lives the closest? One way to do that would be to compare using base 10 blocks. Remember, we're using a flat as a whole, and it's important for us to always compare fractions and decimals using the same size whole. So take a second now, pause, and I'd like you to build the distance from school for each student using base 10 blocks. And if you do that very quickly, my next question is going to be, what is the same about Kaya and Tuan's distance and what is different? So let's take a minute to explore that now. Pause to do this work. Okay, so now that you've built each of these amounts with base 10 blocks, let's take a look. Here we are. Kaya's amount is 6/10. So using our reference as the red flat as 1 whole, this is how far Kaya's distance is from school, from home. Here's Darren's. Darren's amount looks really close to Kaya's, doesn't it? I guess that's because 5/10 is super close to 6/10. And then look at Tuan's amount here. And I asked you to think about something in particular. Do you remember what my question was? I asked you, what do you notice about Kaya and Tuan's distance? So you can look at the decimal place value chart and you might notice something right away. All 3 numbers have a 6 as a digit in the numbers, but only Kaya and Tuan's have 0s and 6s. Darren also includes a 5. When I build Tuan's number like this, so if I just reorganize his hundredths so that I see 6 hundredths here, one thing I can connect is that Kaya has 6/10 in columns and Tuan has 6 hundredths. So we see 6 lined up in the same direction for both of them, but Kaya's are tenths. Kaya's 6 is in tenths place. Her amount is 10 times bigger than Tuan's. So if we could also use a number line to compare these amounts by finding each of these numbers on a decimal number line that is partitioned into tenths. And here I see that Tuan's amount would fall between 0 and 1/10 because, as we can see, he doesn't even have 1/10 distance, a tenth of a mile. He has less than 1/10 of a mile in order to travel to school. Kaya has 6/10, and this yellow one is for Darren. Hi, Darren. But Kaya's distance is 6/10 of a mile, is the distance she travels to school. So hers is the farthest from 0, so hers is the longest distance. Okay, so we have a couple different ways to make sense of this problem. So as you continue to practice and learn more about fractions now throughout this topic and throughout the rest of your 4th grade year, keep in mind to read carefully, because when we read a question